Hello and welcome to Module 5 in our C language series. In today's session, we're going to be focusing on pointers. So what exactly are pointers? And you may recall that it was mentioned in the last session that a pointer is a variable that holds a memory address. And so we could have PTR holding that memory address. This memory address obviously would be the location of another variable in memory. So consider we have num with value 200 having that same address. What's happening here then is PTR is pointing to num. To declare a pointer variable, we need to mention the base type, that would be int, char, float, etc., followed by an asterisk and the variable name. And so here we have an integer pointer declaration. Now coming to the operators, there's two special operators, ampersand and asterisk. These are not to be confused with the bitwise and or the multiplication sign. They're very different in their functionality. So the ampersand is the address of when we're talking about pointers. And so we could have num value 2000 at a memory address. And then if we had a statement num address equal to ampersand num, what we're saying is that the memory address of num will now be stored in num address. And therefore, the ampersand is a unary operator that returns the memory address of the operand. In the case below, the operand would be num. Coming to the asterisk, it's a complement of the ampersand. And if you have a statement like this, the variable on the left-hand side val would contain the value at address num address. What's important to remember is that although the value at address sign, which is the asterisk, is the same as the multiplication sign, they are not related. Also, the address of sign, the ampersand and the bitwise and, are the same, though unrelated. Coming to pointer expressions, and we'll take each of these separately. Let's talk about pointer variables. The best way to understand that is to code. So here we have a float type x and a float type y, and then we have a shortened type pointer. You can see we have the value of x there in float format. Now we are saying PTR equal to ampersand x. So PTR, which is of shortened type, is now pointing to a variable of float type. What happens then if we assign the value at address PTR to y, which is float? So let's execute this now to see what happens. And you can see we have the address because we use %p, that's the format command to get the address printed. But the value printed out is 0 instead of 12.375. So what exactly is happening behind the scenes? Let's close this and look at a slide to understand. So here we have 12.375. We know how to convert the integer part to binary, right? But how do we convert the fractional part? To convert the fractional part, we multiply by 2 until we reach a 1.0. Now, this is not always the case that you will reach a 1.0, in which case you will keep multiplying the result by 2 23 times. Why 23? I'll tell you later, right? But for now, we have arrived at a 1. So we take these digits on the left-hand side of these results and we place them side by side with the integer. So we arrive at something like that. But of course, we can't end there because remember there's still a decimal point and this needs to be normalized. To normalize this data, we need to move the decimal point. How many places? 3 places, so that we arrive just after this 1. And so we end up with something like that. Now we can't end it there. Why? Because floating point numbers in terms of computers are represented using an IEEE 754 specification. You can Google that to find out what it means. Now to get them represented using that specification, we got to find out what is called the exponent. And remember, we moved 3 places, so that 3 is going to be part of our exponent. So we take the 3, we add a bias to it. The bias for floating point numbers is 2 raised to 7, that's 128, minus 1, so that's 127. 127 plus 3 would be 130. So now we have our exponent as 130, right? We have what is called our significand ending in a D there. And of course, this is going to be these numbers, right? This is going to be discarded. So we place all those down, starting with the sign bit, the exponent, the significand. And when we do that, we will have something like this. So we have the sign bit. This is 130 represented in binary, the significand. Now coming back to why we had a 0 printed out, remember that because PTR is of shortened type, what is going to be transferred to Y is only 2 bytes. And going back now to the slide, if you're just going to transfer 2 bytes, all these are going to be lopped off and we're going to be left with zeros. And that's how 0 was printed out. But coming to why I mentioned 23 times, that's because the number of bits we can use to represent the significand are 23. Exponent would require 8 and the 1 bit for the sign bit. That makes a total of 32 bits. Now going back to our code, the conclusion here is that when we declare a pointer, it needs to be of the same type as the variable is pointing to or pointing at. And therefore, if we change that now, you see we get the right result. Okay, so now moving on to pointer assignment, and that too we will understand through code. So here we have integer x, we have 2 pointers of integer type. The value of x is 100. Then we are storing the address of x in PTR1. And now we come to pointer assignment, where we are assigning one pointer to the other. What then will these printfs yield? Let's run this. And you can see now that both PTR1 and PTR2 have the same address. And because they have the same address, the values at those addresses will be the same as well. Right, so that's about pointer assignment. Coming now to pointer arithmetic. With pointers, only addition and subtraction is possible. We cannot multiply or divide an address. When incremented, a pointer will point to the memory location of the next element of its base type. The keywords here being base type. So for characters, that would mean incrementing by 1, just like normal arithmetic. But for all other pointers, the increment or decrement will depend on the length or the size of their base type. So just to show you visually what that means, if I have characters A, B, C, D, then incrementing a pointer, PTR++, for example, would go from 2001 to 2002, 2003, etc. Whereas with integers, the pointer would move from 2001 to 2005, 2009, right? Because each integer has a size of 4 bytes. Right, so let's go and look at some code. So here we have int r, which is a constant integer array and a pointer. And of course, the pointer now is pointing to the first element in the array. While star PTR, what does this mean? It means while the value at address pointed to by PTR is not equal to null. Printf the address and the value. So let's just run this. And you will notice that the address, you can see that's 4 bytes away, right? 0 plus 4, then 4 plus 4 is 8. Now C is hexadecimal for 12. These are all hexadecimal addresses. And then 16 is represented in hexadecimal by 1 and 0. And you can see, of course, our numbers printed out, right? What's important to remember is that integers can also be added or subtracted from pointers. And so if we go back to the code, we could say here PTR equal to ARR plus 2. And then we can print it out, printf %d \n, comma, star ptr. What do you think this will print out? Remember, ARR is pointing to this element. So that's 10, 10 plus 2. That means we're going to move 2 places. This should print out 30. So let's see if that's correct. And there it is. Right? Okay. You can also do a subtraction if you like, but of course you'll have to go to the last element in the array and then do a subtraction. Now moving on. Pointers and arrays. We know that pointers and arrays are closely related. We also know that an array name without the use of index returns a start address of, or the first element of the array, right? Accessing array elements is possible in C, both using pointer arithmetic and array indexing, but most routines for accessing arrays are written using pointers. Why? Because it's easier to read and understand. So let's now go take a look at some code. So here we have encounter, and then we have str1, again a constant string. And we have our pointer. So here we have a loop for counter equal to 0. This you're familiar with, right? But coming now to the pointer part of it, here we have ptr equal to str1. While star ptr, put char star ptr. Note how we are incrementing this. So it's going to print, or rather put the character on the screen and then increment the pointer by 1, right? So when we run this, you will see both these will yield the same results, right? So as was mentioned on the slide, this is much easier to read. We are saying while the value at address is not equal to null, place the character on screen and increment the pointer by 1. Moving on. Write some code. So now you can write this code along with me. Determine if a word is a palindrome. By the way, the code for the previous short programs will all be available in a link in the description. So you can download that code and, play around with it on your computers. Determine if a word is a palindrome. Coming to that, let's go back to code blocks. You can load code blocks now and start a new file. Going to call it palindrome. Hashtag include stdio.h, and then hashtag include stdlib.h, and then hashtag include string.h, as we will be using strlen. Int main. What are the variables that we need? Definitely a string. So char str1, 40 elements there, and then star ptr. Now, to determine if a word is a palindrome, first of all, what's a palindrome? So if you have a word radar, for example, radar, you can see that the letters from the beginning and the end are the same, and that's what is a palindrome. Okay, so to determine if a word is a palindrome, we need a pointer to move from the front, but we also need a pointer to move from the back. And so we're going to have star ptr, and we're going to call that rev, right, or reverse. Now what do? We need to assign the address of the first element in the array to ptr, right? Then we'll ask for the string. Printf enter a string. Now you can put in validation to check that the user doesn't put in more than 40 elements. I leave that to you. And then scanf %s, comma, str1. Right? Now we can have a ptr rev equal to str1 plus, remember str1 is the address of the first element. So we got to go to the last index or the address of the last element. So str1 plus strlen of str1 minus 1. Right? I hope you understood that. Now that both pointers are initialized, while star ptr plus plus is equal to star ptr rev minus minus. Right? This one's moving backwards, this one's moving forward. As long as both letters are equal, this loop will continue. And ptr not equal to ptr rev. Why? Because remember, if we look at a word like radar, at some point both of them are going to land on the address of D. Right? The moment that happens, we need to get out of the loop. Okay, so while this is true, we have just one statement. I'm just putting that, and I'm just putting those curly braces just to make that clear to you that we have this one statement within the block of code. Outside this block of code, we will check if ptr is equal to ptr rev. This means that we have a palindrome. So printf %s is a palindrome, comma, str1. Else printf %s is not a palindrome, comma, str1. Okay, so I hope that's clear. Now let's run this. Let's try radar. Radar is a palindrome. Let's try one that's not. Let's say water. Water is not a palindrome. Okay, so moving on now to the next program that we need to write. Find number of occurrences of characters in a string. Let's go back to code blocks. We start a new file. Number of occurrences. Again, hashtag include stdio.h and then hashtag include stdlib.h and then hashtag include string.h. Again, we're going to be using strlen. Int main and the variables that we need. So again, we need that string. So char str1, again 40 elements. We'll have one pointer that starts from the front, one pointer from the back. Then we need an integer. Now what is this for? This would be a variable that will keep a count of the number of occurrences. So let's call that character counter equal to 0. And now we can initialize ptr equal to str1. So that's initialized to the first address in the string. Printf, enter a string, and then scanf %s, comma, str1. Now while star ptr. Now you know what that means. What do we do inside the loop? We will be having another loop within this one, which will be counting backwards, right? To check for every occurrence of this character. But once we've calculated the occurrences, when we come back into this loop for the next time, this counter should be reinitialized to 0. Is that right? And so we'll say counter equal to 0. We also need to, before we go into the inner loop, have ptr1 initialized to str1 plus strlen of str1 minus 1. Right? You say while ptr1 is greater than or equal to ptr. Right? So this is going to move backwards. While it is greater than or equal to ptr, what do? We check if star ptr1 is equal to star ptr, right? That means an occurrence of the character has been found. Then we increment the counter chr, ctr plus plus. Remember, out of this if statement block, before we go back to this loop, ptr1 minus minus, right? And then here, outside this loop, we need to print the occurrences. So printf, the occurrences of %c are %d, comma, star ptr, comma, chr, ctr. I hope that's clear. Now before we go back into this loop, ptr should increment by 1. So ptr plus plus. Right? So now let's run this and see what we get. Okay, there's no semicolon there. Character. Okay, this is not very nicely printed out. We need to put a \n there so that it's easier to read. So now you can see, yes, the number of occurrences of C are 2, H is 1, A is 2, R is 2. But then again, we are counting A, C, and R. T and E we need, but A, C, and R we definitely don't need. How do we avoid that? One idea is that when the count is more than 1, we can force another character into these places so they're not counted. So let's do that. First of all, we'll have to add a condition here. If star ptr1 equal to star ptr and star ptr, that is the character we are counting occurrences for, is not equal to, and I'm going to be using an exclamation mark. You can use whatever character you want. Then only we increment character counter by 1. Then outside here we check if star ptr not equal to, again, that character, then only do we print out. So what we can do here is we can just indent that line, right? Then we need to check here now. If CTR is greater than 1, we have an if block. Within the block, we'll say PTR1 equal to, we need to bring this pointer back to the last address in the string. So PTR1 equal to str1 plus strlen of str1 minus 1. Okay. And PTR2, now we need another pointer here. Why? Because we're going to use that. We can't move this one. Remember, this is counting the occurrences of that particular character. So here we say PTR2 equal to str1. Right? So this now will move forward. This will move from the back. So while PTR1, right, is greater than or equal to PTR2. Okay. And within this loop, we say if star PTR1 equal to, we check for if it's equal to that particular character, then we force in a character. So star PTR1 equal to exclamation mark. Okay, so I hope you got what I'm doing here. Right, so if character counter greater than 1, then of course we have one pointer starting from the back, another one starting from the front. Remember, we can't use this one because this is what we're checking the occurrences for. And therefore, while PTR1 greater than equal to PTR2, if star PTR1 equal to star PTR2, we force the exclamation mark. Right? And then, of course, PTR1 minus minus. Right? So now let's run this code and see if it takes care of our problem. We need to put a semicolon there. Oh, this should be star PTR2. So now let's enter the string. And you can see that we have this nicely printed out now. C occurs twice, H once, A2, R2, T, and E1. Try another string, occurrences, and there you have O occurs once, C occurs 3 times, U occurs once, R occurs once, E2, and so on. Okay, now moving on. Right, now coming to the next program we need to write, print the substring of a string with length of substring as input from the user. Right, so the user is going to give us the start and the number of characters that they need for the substring. So let's now go to code blocks and we start a new file. When you call this substring, right, so here we start with hashtag include stdio.h, then hashtag include stdlib.h, and then hashtag include string.h, int main. Now the variables that we need a string, of course, and this is going to be a constant. equal to superseded. And then we'll have a character pointer, right? And another one. We'll also need an integer start equal to 0 and end equal to 0. Now we need to ask the user for the start and the end. So printf, enter start and number of characters, right? That is where to stop. So scanf %d, comma %d, comma ampersand start, comma ampersand end. Now what do? We say ptr equal to str1 plus start. Okay, so from which character to start? And then ptr1 equal to str1 plus, let's just say end. Okay, after testing the code we can change it. So while ptr less than or equal to ptr1 within the loop, what do? Printf %c, comma star ptr, right? And then ptr plus plus. Okay, pretty simple. Let's test it out. Okay, what does it say here? str1 is undeclared. Oh, that's because this is not str1, so that's why the error. Enter number of characters. Let's say starting from 2, we want 4. Is that correct? We start from 2. You're not really getting 4 characters. What should we get? This is 2. 1, 2, 3, 4. How do we change this code? We can say here ptr plus end. Let's test it out now. 2, 4. Right, so from 2 we have 5 characters now. So what do we do then? Very simply we say plus end minus 1. Test it out. Let's say starting from 2, 4, and there we have it. Right, starting from 2 we want 4 characters. Test it again. Let's say starting from 1, 5 characters. Do we have 5? Yes. Starting from 1. So you see how that works. Right, moving on. Modify the substring program to accommodate the following. If start is a negative number, counting should start from end of string. If start is greater than length of string, start counting from the 0th element in the string. If end is not mentioned, substring should contain all characters until the end. Right, so I hope you got that. If start is a negative number, that's what we'll deal with first. So going back to the code, let's start with the first modification if start less than 0 code block. Within the code block, ptr equal to str1 plus, and now strlen of str1, okay, plus, and start is going to be negative, so you can put that into brackets. What about ptr1? ptr1 is equal to ptr minus end minus 1. After we've done this, you can say while ptr1 is less than equal to ptr. We have it in brackets, printf %c, comma, star ptr1. And then of course ptr1 plus plus. Remember, we are using ptr1 here because that's going to be, if you think about it, before ptr. ptr is negative, so that's going to start from the back of the array. Okay, so that's about taking care of that one. What about the next condition? Next one says if start is greater than length of string, start counting from the 0th element in the string. So let's do that modification now. So here we'll have else if start greater than strlen of str1, right? Then what do? Code block again. Within the block, ptr equal to str1, right? And then ptr1 equal to str1 plus, again, end minus 1, while ptr is less than or equal to ptr1. Within the loop, printf %c, comma, star ptr, and then what do? ptr plus plus. Okay, so you've taken care of that condition now. Of course, we'll test all these out. What's the third condition? Let's go take a look. If n not mentioned, then substring should contain all characters until the end. So now if n is not mentioned, so else if end is equal to 0, code block, then what do? ptr equal to str1 plus start, because start would still be specified, and then ptr1 equal to str1 plus strlen of str1 minus 1, right? And we'll go till the end, while ptr less than equal to ptr1. In the loop, printf %c, comma, star ptr, and then ptr plus plus. Right, so we've taken care of all the conditions. Our original code will be in another else. So else, and of course that would include a code block, and we'll have this code within that. So you can just move these in, right? Make sure everything is closed. This else should be closed as well. And then of course the main brace should also be closed. Check that we've put our semicolons everywhere. Here there's one missing. So you could choose to just run it and then correct it as you get errors. Right, here too, you need to put a semicolon. So now let's run this. Enter start a number of characters. Now let's test our conditions. We'll say -2, 4. So now if we go to the string, -2 would be here and we want 4 from there. So 1, 2, 3, 4. Is that correct? Yes. What's the next condition? Start is greater than length of the string. So we say 12, 2. It starts from 0 and gives us up till the end. So that works as well. Now we specify no end. So we just say 4, 0. And we start from 4 and it goes up till the end. 0, 1, 2, 3, 4. Right, and it goes up to the end. We've tested all conditions now, and that works. Coming now to arrays of pointers. Pointers can be arrayed like any other data type, right? So just like we do character arrays, integer arrays, we can have pointer arrays. Example would be something like this. So that's a pointer array of integers, often used to hold pointers to strings, right? So in effect, you're going to be creating a two-dimensional array. So let's now take a look at some code, arrays of pointers. And so you can see we have here an array. You can see how we've defined that, because this is actually 2 dimensions. Like one dimension would be this one string, but now there are 4 strings, right? So now if I run this, what actually am I doing in this code? So here I'm just generating a random number. %4 is to generate a random number between 0 and 4. 4 is excluded. Printf greetings. Now I'll come to this commented part later on, but let's just run that. So now if I run this, you see you get a random message there. But if I run this again, I get the same message. Maybe I want a different one, and this is where srand comes in. So we need to include time.h and declare a time t type variable, and then use srand to what is called seed the random number or initialize it. So now when we run this code, you get a different greeting every time. You see? Okay, so that's that. That's about arrays of pointers. Okay, and of course we will be using these more and more as we go along in the code. This is just to show you what we can do with pointers. Now moving on. Single indirection versus multiple indirection. So far we've seen single indirection, right? We've seen a pointer and that variable, and that's single indirection. But we could have multiple indirection as well. So we could have address and another address and then the variable, right? And that's multiple indirection. But having said that, Excessive indirection is difficult to follow and is prone to conceptual errors. Of course, we'll be talking more about indirection, especially when we talk about linked lists and binary trees. Coming now to initializing pointers. Pointers after declaration and before assignment contain an unknown value. Therefore, using pointers before they are assigned could crash your program as well as your operating system. Therefore, it's good to assign a null to a pointer to indicate that it points to nothing when you declare it. But using a null pointer on the left side of an assignment statement risks a program crash as well as an operating system crash. Right? So we need to be careful of that. How are functions compiled and called in C? Because now we're going to be talking about function pointers. So when compilation happens, the source code is transformed into object code. We already know that. And an entry point to the function is established. When you call the function, a machine language call will go to the entry point. Coming to function pointers. A function is not a variable but has a physical location in memory, which means it has an address and therefore can be assigned to a pointer. The address of the function is the entry point of the function. We can call a function using a pointer. So now we're just going to write code and you can follow along with me. We start a new file. We'll just call this function pointer. Save. So now hashtag include stdio.h and then hashtag include string.h and hashtag include stdlib.h. Okay, we are going to have a separate function. We'll do functions in more detail in the next session. But for now, we just have this one function that's not going to return any value. So it's void and it has pointers char star s1 comma char star s2. And now we define our function pointer. So CMP and the brackets around this, that name is so that the compiler can interpret this correctly. Otherwise we'll get warnings. Okay, so semicolon there. Now we start our main function, int main. Now within main we have two strings, char str1, that's going to be of 60 characters, and str2 of 60 characters as well. Then we have our declaration of the function pointer. So int star, I'm going to call it func underscore ptr, just so that we know that it's a function pointer that we are talking about here, right? And now we'll assign that function pointer to strcmp, just like that, right? Now printf, enter a string, and then scanf, comma str1, and then we need another printf, enter another, and then scanf %s, comma str2, right? Then we just call the function passing in str1, str2, and the function pointer. Okay, that's all in main. Now we can start our next function, which is void check, and of course char star s1, right? Or you can call it str ptr1 if you like. It doesn't have to be the same. Char star str ptr2, comma int, and I'm going to call this star cmp, right? And that of course is a function pointer. Within this function we will just check if not star cmp str underscore ptr 1. So we'll have these in brackets, and str underscore ptr 2, right? Then printf, right? Remember, if strcmp returns a 0, which is this particular condition, then we print strings are equal. Else printf strings are not equal. And that's all. Now we run this. Let's test it out. Let's say equal, unequal. Strings are not equal. Let's now try equal, equal. Strings are equal. Okay, so that's about function pointers. Moving on, we come to dynamic allocation. For this, we need to understand how memory is managed in terms of your program. So here we have program code, then we have global variables, we have the heap, and we have a stack. The stack holds local variables, return addresses of function calls, and arguments, that is the parameters that we're sending to the functions, as we saw just now. The heap is a region of free memory that is used for dynamic allocation, right? So we can assign memory from the heap according to our requirements, right? That's a free region. You can see that stack has an arrow pointing down because it's like a stack of plates, right? So everything is placed one on top of the other. The heap, on the other hand, has an arrow upwards. Now, having seen this, let's talk about the core of C's allocation system. We have two functions, memory allocation or malloc, and this has a prototype, which is void star malloc and the size t, number of bytes. Okay, size t is an unsigned integer defined in stdlib.h. Okay, so we can assign malloc to any type of pointer. Successful call returns a pointer to the first byte of memory allocated from the heap. Unsuccessful call would return null. We have another function called free, which we need to use to free all pointers. Prototype is void free. Both functions require header file stdlib.h. Write code to allocate 1000 bytes of memory. The data type is character. So let's now go to code blocks again and start a new file. Allocate memory. So hashtag include stdio.h and then hashtag include stdlib.h. right? Int main, the data type is character, so the pointer will be of character type, so char star ptr, right? And then we can say ptr equal to malloc, and then we just need 1000 of those bytes. That's all. So what you can do is you can introduce a check here. You can say if not ptr, which means if ptr is a null, then what do? We will print out an error. Okay, so print f out of memory, and you can, if you want to, exit the program. So we'll introduce a code block for that if statement, and within that we'll say exit, and remember exit 0 means operation or execution successful. Anything other than that is an error. And so we can exit 1, right? Else we can just printf memory allotted or memory assigned. So now if we run this, memory assigned. Moving on to the next, write code to allocate space for 100 integers. I'm going to write a new program. We need an integer pointer. So int ptr1, and because integer is 4 bytes, what do? We will say here ptr1 equal to, sorry, this should be a pointer, and then we say ptr1 equal to malloc, that's 50 integers, and then we use the size of operator, size of int, and that's it. And again you can put in that same check, if not ptr1 code block printf out of memory and exit 1, else printf memory assigned to 50 or 50 integers, right? And let's put a backslash in there, so the next message comes on a different line. So now we run this. This is memory assigned for the characters, and this is memory assigned for the integers. Right, coming to the next. Allocate space for a string dynamically, request user input, and print the string in reverse. Let's go back to code blocks now. For this, we will start a new file. So let's call this allocate mem reverse string. Bit of a long name, but you can have a shorter name if you like. So here we'll have hashtag include stdio.h, and then hashtag include std lib.h, and then hashtag include string.h. Now we have int main, and within that we need our char star str1 or star, you can name it str1, str2, whatever you like, and then int counter. Okay, now we say here if not, now we're going to combine the malloc and the checking for whether memory is allocated or not in one statement. So if not str1 equal to malloc of 50, let's say, then printf out of memory, right? And then exit 1, right? Else printf memory assigned, please enter your string. Scanf. Now, of course, since we have more than one line of code, we need a code block there. And of course, then scanf %s, comma, str1. Right, so now the array has been dynamically allocated, right? It's got 50 elements. Now we've got to reverse that string. For counter equal to strlen of str1 minus 1. Then counter greater than equal to 0 and counter minus minus. And we'll just use put char now to place the character on screen. str1 of ctr. And that's it. Now we learned that we can free a pointer, right? So after this and before the end of main, we can use free and say free str1, and that's all, right? So now let's run this. Okay, there's a semicolon missing somewhere. Please enter a string, hello, and you can see that's printed in reverse. Good practice is to free memory so that it can be used for something else. Right, moving on. Dynamically allocate space for a two-dimensional array of 5 by 4 and print the first, second, third, and fourth powers of numbers 1 to 5. Now, allocating space for a single dimension is easy, but when we're talking about allocating space for a multi-dimensional array, it's better to pass the entire block of memory to the function, where the function will then give it the required dimensions, which means we pass 5 multiplied by 4, that's 20, multiplied by size of int to the function, and then the function will specify dimensions. So let's go and write that code now. So let's start a new file. Dynamically alloc to dim. Hashtag include stdio.h. Hashtag include stdlib.h. And hashtag include mat.h because we're going to be using the pow function. So now we have our declaration of the function that we're going to be creating later. So let's call that powers. And we'll be passing in int 5 by 4. Now we write our main function. So int main. And we start with int star ptr. And then ptr equal to malloc 20 into size of int, right? Then we check if not ptr, and we can just say printf out of memory, and then exit 1. Now we don't really need to use the else. I've been using it just to show you blocks of code. But in effect, this exit is going to take us out of the program. So it's never going to reach this point, right? If we exit. So now we can just call the function with the pointer. And you can see here we're sending the entire block of memory that we had allocated there. And that's all in main. Now coming to the function we need to write, which is powers. So void powers, and we have here int ptr 5 4. So now int x comma y, and then for x equal to 0, x less than 5, x plus plus. Right? This you're familiar with now. Within that, for y equal to 0, y less than 4, y plus plus. And then within this inner loop, what do? We say ptr x of y equal to, we need to cast pow, so int pow x, remember, is 0, so x plus 1, y is also 0, so y plus 1. And now, of course, this loop will continue. Once we come out of these two loops, we need to print out. So over here, we say for x equal to 0, x less than 5, x plus plus. And then we have the other loop for y equal to 0, y less than 4, y plus plus. And within that inner loop, we will just printf %d, comma, ptr x y. Right? And for the next number to be on the next line out of this inner loop, we can say here printf \n. Right? So now we can run this and check the results. And so you can see we have the values printed out. Of course, they're a bit crowded, so you could put in a space there. We could say here %d and just that space. Now you can see those are nicely spaced out. We do get a warning here, but as you can see, the program works, so we can safely ignore that warning. Problems with pointers. The uninitialized pointer, misunderstanding the use of pointers, comparisons or making comparisons between pointers that do not point to a common object. These are the common problems with pointers. The best way to understand these is to find bugs in code. So here we go. We have int x and then star p, that's an integer pointer, no error there. X equal to 10, star p equal to x, is that correct? Okay, first of all, there's a semicolon missing there. What else is wrong? We cannot have star p equal to x because then we are saying assign 10 to some unknown location, right? So this should be ampersand x, meaning we have an address there assigned to pointer. Okay, what about the next one? Int x star p, x equal to 10, p equal to x, and printf star p. Is it going to actually print 10? No, it's not. Because p is supposed to contain an address. Next, what about this one? Char str1, str2, and then we have ptr1, ptr2. Of course, we don't need two semicolons there. The semicolon here is missing, as you may have guessed already. Can we do something like this? No, conceptually it is wrong. We cannot compare one pointer to another and then, printf something like that, right? Now coming to the next one, int first r 10, second r, int star ptr, counter, pointer equal to first r. For counter equal to 0, counter less than 20. Now we're assuming here that both these are back to back in memory, which may not be the case, and therefore we cannot do something like this. What's the bug here? If we go through the code, char star ptr1, str1 of 80, that's fine. Within the do while loop, we are asking user for the input while value at ptr1 not equal to null, printf %d, and then of course we are incrementing ptr1. Now for the first time, ptr1 is pointing to the first element in str1, so it's fine. But for the second, third, etc. time, remember ptr1 is going to be incrementing by 1. So when it goes back into the loop, we don't know where it is. And therefore, this particular line needs to be moved into the do while loop. Right? So I hope that's clear. That's all for today. In the next session, we'll be talking in detail about functions. So till then, take care, stay safe. Bye.